Hello everyone, today we'll be discussing homework related to chapter section 8.3, Properties of Planes from McGraw-Hill Ryerson. As per usual, I'll go over some selected exercises from the ones that were given in class. And that's all for me talking about what we're going to do. Let's just jump straight into it. So, question 1, we have determine if each point lies on the plane. So, geometrically, we think about planes as being some two-dimensional surface that lives in 3 dimensions. But algebraically, we can just think of it as every point, and a point is an x, y, z trio, that satisfies this equation in particular. X plus 2y minus 3z minus 5 equals 0. So we're just looking to see if the point satisfies this equation. Okay, so let's begin. And we have 5, negative 3, negative 2. Meaning, if we plug this into the equation, we're going to get 5 plus 2 times negative 3 minus 3 times negative 2 minus 5 equals 0. So is this true? 5 plus 2 times negative 3 minus 3 times negative 2 minus 5, 0. So left-hand side equals right-hand side. This is a mathematically true statement. Therefore, M is on the plane. Let's do C. That's P is negative 7, 0, 4. So we get negative 7 plus 2 times 0 minus 3 times 4 minus 5. Does that equal 0? Let's see. Minus 7 plus 2 times 0 minus 3 times 4 minus 5 minus 24. Is that a mathematically true statement? No, so I'm going to put 0. So therefore, P is not on the plane. Okay. Moving on, we have E, let's do. Question E is R 0, 0, 5. So what is this going to be? This is 0 plus 2 times 0 minus 3 times, minus 3 times 5 minus 5 equals 0. So we get 0 minus 20 on the left-hand side, and this clearly does not equal 0. So therefore, it's a false statement. That's why I put the not equals. So therefore, R is not on the plane. So that's the gist of this question. Just plug and check whether your point satisfies the given scalar equation of the plane. Okay. Next question, find 2 vectors normal to each plane. Okay. So I'll do B, D, and F for this one, let's say. Okay, so how do you find a normal given a scalar equation of the plane? This is actually quite simple. You can just extract the normal vector from the coefficients in front of x, y, and z, respectively. So for this guy, we have 6x minus y plus 4z, 6x minus y plus 4z plus 8 equals 0. Okay, so then the normal, I just look at the coefficients in front of the x, y, and z variables. That's 6 minus 1, 4. Okay, you ignore that d value. That's one normal. So you probably have noticed I did not put square brackets. That's important. 6, negative 1, 6, negative 1, 4. Yep. And obviously another normal, if you have some plane, and you have some plane in 3 dimensions, you have one normal that points like this, and obviously another normal would be this guy right here. So negative n, right? If this is n, this would be negative n. Okay, so you can write that down. That would be negative 6, 1, negative 4. Beautiful. Let's do d. D is saying 5y equals 8. Okay, so I'm just going to put this into its proper scalar equation of the plane form. So that'd be 5y minus 8 equals 0. Just so there's no ambiguity of what the scalar equation is. Now we can look at the coefficients. So there's nothing in front of the x, so it's 0. There's a 5 in front of the y. There is no z, so 0. And then negative n would be 0, negative 5, 0. Perfect. And f. So for f, we have minus x, minus 3y, plus z equals 0. So then for n, we have minus 1, minus 3, 1, and then minus n would be 1, 3, negative 1. Okay. Moving on to question 4. Write the scalar equation of each plane given the normal end and a point P on the plane. So these problems, you have to know the general form of the scalar equation of a plane. It looks like this: ax plus by plus cz plus d equals 0. Okay, that's the general scalar equation of the plane. And remember, n is the normal vector, which is just a, b, c. Okay, and we're going to use both these facts to pretty much just find d, and that completes the scalar equation of the plane. So let's do a, d, and e. It's from random choice. So the first one, we're given the normal vector and the point. So we have, this is how the scalar equation looks so far. It would be 1x minus 1y. I'm writing the ones, but I'm not going to be writing it down shortly after, if it's a 1, plus 1z, okay, plus d equals 0. And now we have to find d, but let's just make this look nicer. X minus y plus z plus d equals 0. Now using the known point, let's find d, and then we can complete the whole scalar equation. So we can write this now as sub in the known point p2 negative 1, 8. So we get 2 minus negative 1 plus 8 plus d equals 2 minus -1 plus 8, 11. So d is equal to -11. Meaning the full equation looks x minus y plus z plus 11 equals 0. That would be the full equation. Okay. D the normal vector is -9, 0, 0. So that means the scalar equation looks like -9x plus 0y plus 0z, so we don't have to write anything there, equals 0. Okay, but we have our known point on the plane, which is -2, 3, -15. Oh, sorry. Crucial detail. The plus d, right? That's what we're after. -9x plus d equals 0. So -2, 3, -15. So that means, subbing everything in, we get -9 times -2 plus d equals 0. So d is equal to 18, so -18. So we have -9x minus 18 equals 0. You could factor a negative and then divide by it, so it would be 9x plus 18 as well. That also works. Okay. Let's do E. Just then the normal vector is 4, -3, 2. Oh. 4, -3, 2. So the scalar equation then would be 4x. 4x minus 3y plus 2z plus d equals 0. Our known point on the plane is 6, 3, -4. And then, sub that in, 4 times 6 minus 3 times 3 plus 2 times -4 plus d equals 0. Then d would equal 4 times 6 minus 3 times 3 plus 2 times -4. You get 7. Then moving it over to the other side, you get -7. So the final equation is 4x minus 3y plus 2z minus 7 equals 0. Okay. Oh, I screwed up here. This should be a minus. Okay. Question 6. Write a scalar equation of each plane given its vector equation. So we'll do BDF here. So to find the scalar equation of a plane, we need the normal vector. And how can we find the normal vector now? So that's the goal. Well, we're given the vector equation of each plane. We can take those two direction vectors, and now we have to think of an operation that if we give it two vectors, gives us a perpendicular vector to both. Well, that's precisely what the cross product from unit 7 does, right? So we can take those two vectors, the direction vectors of the plane, take their cross product, find a normal vector, and then we're golden. The only other issue is we're going to have to find D again, as always, but we can use the position vector of the vector equation to find D. So combining from part 4, but also applying the cross product as well. That's what we're going to be doing. So let's do B, D, and F. 6b. So we have the two vectors 3, -2, 4, and 5, -2, 6. So I'm going to take their cross product. So I got I have -2, 4, 3, -2. Okay. And then I have -2, 6, 5, and -2, 6, 5, -2 again. So you start from the second component and then cycle your way back through until you hit the second component again. Just want to make sure that's right. -2, 4, 3, -2. Perfect. So then cross, 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 and I like to indicate that I'm doing subtraction. So in the vector we get, we'll just call it V. Actually, let's call it N, because it's going to be normal. Normal vector. Three, 2, 6, 5. Yep. Okay, so what do we get? -2 times 6 minus -2 times 4. -4 is the first component. 4 times 5 minus 6 times 3, 2. 3 times -2 minus 5 times -2. Oh, sorry. 3 times -2 minus 5 times -2. 4. Okay, so in the scalar equation we end up with would be -4x plus 2y plus 4z plus d equals 0. And at this point now, we can sub in the position vector of our plane, which would be this guy, 5, -2, 3. It's the same process we're doing for all these questions. 5, -2, 3, so let's sub that in. So we get -4, 5. So then D would be equal to 4 times 5 plus 2 times -2 plus 4 times 3. -12, moving it over to the other side, we get 12. So the final equation would be -4x plus 2y plus 4z plus 12 equals 0. Okay. The answer they got in the book, I just want to see if mine matches that. Oh, well, they used a different scalar multiple of the normal vector. So my answer differs from that by that point of view. But it is still right. Like what I did is still right. So this unit as a whole, you're going to look at the book a lot, and wonder my equation or my answer doesn't match. And that's okay, because there's not just one unique answer for a lot of these problems, which makes, I guess, Ms. Cranick's life a lot more difficult, but that's how this unit goes. Okay, moving on. We got D. So same deal. I'm going to do the cross product between the two direction vectors. So it's going to be 5, 2, 6, 5, 2, 6, 5, and then negative 3, 1, negative 3, 1, 3, negative 3. Cross, 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 cross. Add your minus signs. Okay, let's find n. 5 times 1 minus negative 3 times 2. That's 11, the first component. 5 times 1 minus negative 3 times 2. Yep. Next component, 2 times 3 minus 1 times 6. 0. 6 times negative 3 minus 3 times 5. So 6 times 3 minus 3 times 5 minus 33. Okay? So then the scalar equation we get with the D parameter involved is 11x, no y, minus 11x minus 33z plus D equals 0. Okay, and now we can substitute our, I'm going to just call this line subbing in position vector of plane. I'm going to try to dedicate this line to that, going horizontally across. So it's the same procedure. So this time the position vector we're going to sub in will be doing question D, yeah. So it'll be this guy, 9, 1, negative 8. Okay, so 11 times 9 minus 33 times negative 8 plus D equals 0. D equals 11 times 9 minus 33 times negative 8. 363, so it's going to be minus 363. And then therefore, we have 11x minus 33z minus 363 equals 0. Okay. Nine, 1, negative 8. 9. Yeah. Okay. Seems the answer in the book is way off. F. So crossing the two vectors. So what do we have? 2, 0, 3, 3, 0, 2. So 0, 3, 2, 0, 3, 2, 0, 3, 2, 0, 3, 2, 0, and 0, 2, 0, 2. I guess I'm doing F. Yeah. 0, 3, 2, 0, and 0, 2, 3, 0. Should make sure I did that right. 0, 0, 2, 3, 0. Okay. Cross, 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 cross. Minus signs. 0 times 2 minus 0 times 3, 0. 3 times 3 minus 2 times 2, 5. 3 times 3 minus 2 times 2. Yep. 2 times 0 minus 3 times 0. 0. 0, 5, 0. Okay, so then the scalar equation we get this time would just be 5y plus d, including the d parameter, equals 0. Now we sub in our known point, so I want to indicate we're doing that for all these problems here in this line. Okay, so here the known point on the plane, or the position vector on the plane, is 3, 2, 1. That's this guy right here. So subbing in 3, 2, 1, we just sub in 5 times 2 plus d equals 0. And then therefore d equals negative 10. Okay, so we get 5y minus 10 equals 0. Perfect. Three, two, one. Yep. Alrighty, and that concludes this chapter section. I'll see you when we start looking at intersections of lines in 8.4. Thanks, guys. Have a good day.